Good day, everyone. You are welcome to the tutorial on brake design. In this question, we are going to take a look at the design of band and block brake. The question says that the band and block brake shown in figure below, the band is lined with 12 blocks, each of which sustain an angle of 15 degrees at the center of rotating drum. The thickness of the block is 75 millimeter and the diameter of the drum is 850 millimeter. We are to find the least force required at C for the block to absorb 225 kilowatt at 240 RPM, and we're given the coefficient of friction between the band and the block to be 0.4. Now let's begin. Solution. Let us take a look at our given. We're given the number of block n to be equal to 12. Then we're given the angle of wrap 2 theta to be equal to 15 degree. From there, theta will be equal to 7.5 degree. Then we're given the thickness of the band T to be equal to 75 millimeter, which is equal to 0.075 meter. Then we're also given the diameter of the drum to be 850 millimeter, which is equal to 0.85 meter. Also, we're given the power to be transmitted to be equal to 225 kilowatt, which is equal to 225 times 10 raised to power 3 kilowatt. Then we're given the speed of rotation to be 240 RPM, and we're given the coefficient of friction to be 0.4. Now let's begin. Now the least force required at C, let it be P. At this point C, let that force be P, and we know that the diameter of the band D is equal to diameter of the drum plus twice the thickness of the band, and this will be equal to 0.85 plus 2 times is 0.075, and this gives exactly 1 meter. Again, we know that power absorbed P is given by the effective tension on the band, which is T1 minus T2 multiply pi dn all over 60. Then we will make the effective tension the subject of the formula. We have power multiplied by 60 over pi dn. We'll substitute our value. We have 225 times 10 raised to power 3 multiplied 60 divided by pi times d, which is 1, times n, which is 240. We are going to have 17,900 Newton. Then we also know that the ratio of the tension on the tight side to the slack side, which is T1 ratio T2, is given by this expression 1 plus mu sine theta over 1 minus mu, tan theta rather, tan theta over 1 minus mu tan theta raised to power n. When we substitute our value, we have 1 plus 0.4 tan 7.5 over 1 minus 0.4 tan 7.5 raised to power, our n is the number of blocks, which is 12. When we evaluate this one, we are going to have 3.55. Now, let us recall our two equations. The first equation is T1 minus T2, which is equal to 17,900. Call this one equation 1. We have T1 over T2, which is equal to 3.55. Call this one our equation 2. So when we evaluate the two equations, solving equation 1 and 2, we are going to have T1 to be equal to 24,920 Newton, and we're going to have T2 to be equal to 7,020 Newton. Now, let us take moment about O. Taking moment about O, then we have P times 500 plus T1 multiply 30 is equal to T2 multiply 150. Then from here we have 500 P is equal to 150 T2 minus 30 T1. Then we have P is equal to 150 times our T2 is equal to 7,020, then minus 30 T1. Our T1 is 24,920 divided by 500. And when we do so, we are going to get our power. We are going to get the force P, which is equal to 610.8 Newton. Thank you very much.